OSI model is a 7-layer model that we use in data networking to provide us with some modularity and some interoperability. If we take a look at the diagram here, you'll notice that this is a 7-layer model. And typically we start out down at the bottom layer, calling it the physical layer, or layer 1. Right above that we have the data link layer, or layer 2. Above that is the network layer, or layer 3. We then have the transport layer, we call that layer 4. The session layer above that, we call that layer 5. That's followed by the presentation layer, sitting right above that, and that's layer 6. And then we have the application layer up at the top, and that is layer 7. Now this is a model that was developed in the early 80s, and around that time, networking was starting to grow rapidly. New technologies were being introduced. There was a lot going on in those days. Around the mid-80s, companies started to experience certain issues as they expanded. And what they were finding is that when you had different networking vendors that had their own model, it was hard to get the different vendors to interoperate with one another. In order to address this problem of interoperability, the ISO, which is the International Organization for Standardization, created this OSI model. And again, the intention was that it would give us a set of standards here and provide some interoperability, some compatibility, some modularity. One thing about the OSI model is that if you develop something that operates at the data link layer, you can be a specialist in the data link layer. You can understand all the ins and outs of that layer, and you don't need to understand the details of other layers. All you need to know is how to get them to communicate with the layer above and the layer below. Now, what happens is this reference model here, OSI model, it separates our networking functions into multiple layers, and we can use that as we troubleshoot. Now, each of these layers is going to provide services to the layer above it. So for example, if I have an application that wants to send some traffic on the internet, it's going to use the application layer to pass that data down this OSI model before it gets to the wire. As that data is passed down through each layer, services are provided to the upper layer. Now again, this simplifies the implementation of our networking functions and provides a lot of interoperability. Now there are other networking models that exist today. However, most people are going to develop and focus on the OSI model, again, because people want to have interoperability these days. The bottom of the OSI model, layer 1, we do call this the physical layer. Now the physical layer is responsible for the definition of the electrical, mechanical, procedural, and functional specifications that are used to activate the link, to maintain the link, to deactivate the link when communication is finished. So the types of things that you're going to see here at the physical layer will be things like physical data rates and maximum transmission distances because of the type of transmission we're doing. So sort of laws of physics playing a part here. Other attributes would be voltage, or the timing of the voltage levels, things along those lines. Now when we think about the physical layer, what we have to imagine is we have physical devices, but there are certain things we can't see here, obviously, like the voltage. But we might be dealing with physical media. That would be, for example, an Ethernet cable. That would be something tangible, something physical that resides at layer 1 of this OSI model. Okay, so that's what we see at layer 1. We see the physical media and all of the properties that surround it. Moving on to layer 2, we call this our data link layer. Now the data link layer is what defines how my data is going to be formatted for transmission. It also defines how we're going to access that physical layer. And so at the physical layer, we could have different types of media. For example, your media might be Ethernet, or it could be fiber optic cable. Whatever the case may be, we need to have a definition of how we're going to access that. And that's what layer 2 is responsible for. Now, layer 2 also makes sure that we have a reliable delivery of the data. Now, it doesn't do any error correction, but it will do some detection to let me know if something didn't work right. Now, as far as devices go, we do have physical devices that are designed to operate at layer 2. And that would be, for example, a bridge or a switch. Bridges and switches are layer 2 devices. Moving up to the next layer, we have layer 3, or the network layer. Now, the network layer is designed to provide connectivity between two systems that are on different networks. And the way that we do this is through a logical addressing. The most common logical addressing that we deal with these days is IP version 4, and closely behind that in popularity is IP version 6. Now, these are logical addressing that layer 3 uses to determine best path. That best path calculation is done through a routing protocol in most cases. It could be done statically by an administrator. Now, best path is selected and our data is transmitted. And remember that each layer provides services to the layer above. So when layer 3 figures out the best path, it's going to take that information that it wants to send to a next hop device, and it's going to pass it down to layer 2, and layer 2 is going to provide a service. What kind of service might that be? Well, remember, layer 2 helps me to access the physical media, to put that data onto the wire. Now, we do have layer 3 devices. An example of a layer 3 device would be a router. It's commonly said that routers operate at layer 3. The next layer in the 7-layer OSI model is the transport layer, or layer 4. The transport layer is responsible for segmentation of my data and reassembling that data when it's received on the other end. So an example would be a large corporation, and you want to transfer files from one location to another location. And if that has to be done reliably, because the data is important, well, the transport layer has a service called the Transmission Control Protocol, or TCP, that can do that for us. It's not every case that traffic needs to be sent reliably, and layer 4 has a method of transport that can send traffic unreliably, and that's the User Datagram Protocol, or UDP. Now, just because it's said to be an unreliable protocol doesn't mean that it doesn't work. It just means that it is using the service without any acknowledgement of the receipt of data. Transport layer also provides error detection and recovery. It does flow control, and that's all used in our reliable connections. Layer 5 is the session layer, and the session layer establishes, manages, and terminates sessions between two hosts that want to communicate with one another. The session layer also does synchronization between the presentation layer of the two host devices. Presentation layer sits above the session layer at layer 6. Now again, this would be the service that the session layer provides for layer 6. So an example would be a web server that has a number of users, and they are communicating to processes that are running on the server, and they can be communicating with those processes at any given time. Something has to keep track of which user communicates with each process, and that's what this session layer helps us do. And moving up another layer to layer 6, the presentation layer. This is the layer that deals with how the information that is sent up at the application layer is going to be readable by the application layer at the other end. So it's all about how the data is presented for readability. So an example here would be some program that communicates with another computer. One is using EBCDIC, or EBCDIC, and the other is using ASCII text to represent the same characters. Now these are two different formats, but each of them are representing the same characters. They just do it in a different way. So the presentation layer would have to translate between these data formats using a common format. Finally, up at layer 7, we have the application layer. Now, the application layer is the layer that's closest to the user. Now, this layer is something that uses network services to provide a service to an application. So there are applications that do not have the TCP/IP stack, or more specifically, that do not use the OSI model because they don't communicate on the network. But if an application is going to communicate on the network, then it's going to have to use the application layer to start to pass its traffic through this 7-layer model and then down to the wire for data transfer. So in reality, the application layer is not providing service to another OSI layer, but rather it's providing service to an application that sits outside of this OSI model. Now, the application is going to establish the availability of different communication partners, and it's going to synchronize the establishment agreement. It'll do some error recovery and control of my data integrity, but all in all, as a networking person, we generally don't work at the application layer or the presentation or even the session layer for that matter. As a security analyst, you do need to be a little more aware of what's happening at layer